Okay, sorry about that. I guess I thought I had tested things, but there is something that I hadn't figured out before. So what this rows and columns mean is as you build your table, there should be one variable that's sort of across the top and another variable that's down the side. And so that's just what it means by rows and columns. So the answers that are going to determine what the row labels are is in column C1, for example, and the answers that determine what the column labels are going to be are in column C2. So here, like the soda options are going to go down the left side of the table, A, B, C, D, E, and the cigarette options are going to go across the top. They'll be the column labels. Okay, so that's what I was supposed to do here. Sorry for that, that misstep. So under statistics, these are still set up from what we did before. So we will just hit OK and see what we get. All right, so here's our summary. There's a lot of small numbers in this table. So here, like, there's a lot of people who prefer coffee and never smoked. The most is the people who drink soda and never smoked, and the third most are the people who don't drink caffeine and never smoked. There are a lot of numbers. There's like a 5, bunch of 4s, a 3, and a 1. There's only one person who doesn't smoke and drinks coffee. That is not good for the chi-square test working properly. So there's no zeros, so we've got a p-value down here, but we really don't like to have these numbers that are this small, these 1s and 3s and 4s. So the chi-square test ran, so in that sense it was a good practice run, but these numbers are so small that the chi-squared test really isn't great for analyzing this data. So what do we do? Well, you could try to find another test, but this is the only this chi-squared test we're using is the only test that we're going to use in this class that applies to comparing two categorical variables. Your other options are to try to combine some answers, like you could put the current smokers and smokers who would quit together so that at least there would be no 1 here. This would be 4 total, this would be 8 total, this would be 30 total. You could lump them together so that they would give bigger answers. But I feel like I would want to distinguish the people who quit smoking from the people who are still smoking. So I guess the best option would be to try to get more data to beef up these numbers a little bit. If you could talk to another 200 people, maybe you could find a few more, maybe you could get these numbers bigger so that all of these numbers would be a little bit bigger, and then we could trust our tests a little more. So that would be the ideal solution, is just say 279 wasn't a big enough sample. Maybe we could go for 1,000 people, and then maybe there wouldn't be any small numbers left in the table, like small meaning less than 5. Okay, so what was our p-value? Let's just assume this worked okay. So the p-value is 0.005. That's 0.5%. So that's lower than our typical testing levels of 1 and 5%. So we do have strong evidence of an association. And where is our association? It looks like all these numbers are kind of close. This one down here is way off. We had way more no smoking, no drinking people than expected. That's the one that's furthest away from what you would expect. And these numbers at the top are sort of skewing towards these smokers a little bit, actually. There's sort of more smokers than expected up here. There's bigger that by 1 or 2, which are small, but all of our numbers are small here. So yeah, I'm not sure where the differences came in exactly. There's 15 boxes. It's hard to read into it, but that's the p-value. It's small. Not great because of the small numbers in the table, but small p-value means we reject the null hypothesis. it seems like they're not independent variables, we do have evidence of an association. So that's what raw data looks like coming into Minitab. We'll have more examples of that with other tests going forward so that we can practice that a little more.